Hello, everyone. Hopefully you can hear me. Everything should be set up. Welcome to my talk. Today I'm going to be talking to you about how to try and make your APIs as user-friendly as possible and relying on the compiler to try and give you that sort of edge in terms of catching mistakes before they get to production. So this topic is correct by construction, APIs that are easy to use and hard to misuse. So what do I mean by correct by construction? When I was preparing for this talk, I realized that actually there was a previously defined set of books and things that actually talk about this in a much more specific than my sort of armchair version. So if you're here looking for that, I'm sorry, this is not going to be what you were expecting. But what I mean by correct by construction is if the code compiles, it's correct. Probably. Obviously, we can't achieve that under all circumstances, but it's a goal. And hopefully, obviously, wrong code should not compile. That is, you should find the errors as early as possible. How am I qualified to talk about this? I've been doing this for a good old while now, and I cut my teeth in the games industry back in the day when there wasn't the ability to supply patches. A patch would require a new CD to be sent out to people. So getting things right was really important. I've also worked at a C++ tools company, and I worked at Google, and most recently I've spent 10 years in finance, where the kind of mistakes you make are very, very expensive indeed. So I've been incentivized to try and write code in a way that means that silly mistakes are caught by the compiler. Obviously, this is not a replacement for testing, and it's not a replacement for a good solid design, but if you can meet somewhere in the middle and mean that you can hand code onto somebody else that they can then use without having to think too hard, you're doing something right. C++ gives us a wide toolbox of options to pick from to sort of provide this kind of functionality. We've got constancy of various types. We've got enumerations, lambdas, the terribly named RAII. Static code analyzers are coming into the fore more and more with things like Clang Tidy. And we have a very strong type system. You might be thinking to yourself, I don't make APIs. But we all make APIs. Every piece of code we write is an API to something. And this tweet, I think, captures what I think about coding, which is that code is a way that you treat your coworkers. So this is Michael Feathers tweeted this out a few weeks back. And it really struck a chord with me, especially when you consider that you tomorrow are your own coworker today. So if you can make something easy for yourself to use, you'll thank yourself, your past self in the future or something. So I'll make no apologies for drawing from my experiences in the trading world for the last, as I say, decade. And I'm going to throw up some code here and go through a few simple finance concepts just to sort of illustrate the kind of things that you can do and the kind of changes you can make to your APIs to make life easier on yourself. So this is just a made-up API to send an order. And an order is a message to an exchange, that is, like a stock exchange, that says I'd either like to buy or sell some kind of stock or future or option or whatever for some quantity at some price. And here I've called symbol the sort of the name of the stock ticker or whatever, like this would be GOOG for Google or APPL for Apple, those kinds of things. And I've used a Boolean to say whether I'm buying or selling, int quantity and double price. And so if I was in possession of 100 Google shares, which would be a lovely thing to be, I might want to sell them, and I could write code like this, where I send an order for Goog, false because I'm not buying them, 100 shares for $1,000, which is not an appropriate price for what it's worth for Google shares right now. I actually don't know what they're trading at, but this is not financial advice. The problem with this API as written is that you've probably already spotted, it's really, really easy to make an expensive mistake like this, where I am sending an order, and instead of selling 100 shares for $1,000, I'm selling 1,000 shares for $100. And that's the kind of thing that your boss tends to not like. You might reasonably expect the compiler to warn you about this, but GCC at least is silent on this, even with WALL, W extra. So I advise you, and I'll mention this many times, to turn on all the warnings all the time and preferably make them errors. But even the default warnings, or rather the default all warnings and the default extra warnings, don't think that this is a problem, because C++ says it's completely reasonable and fine to take an integer. Let me just go back. So that 1000.00 is perfectly representable as an integer. So the compiler says, that's fine. You may have spelled that funny, but I can turn that into an integer, no problem. So the first section of the talk is going to be on strong value types. And in other languages, and I spent a while writing in other languages, notably Java, these are sometimes called tiny types. And so when I was looking for strong tiny types, I found a picture of an ant, and I thought that sort of sums it up. But we sort of commonly know them as strong value types there, and these are hopefully going to save us. So the first thing you might want to do is you might try at least something like this, where you want to say, well, instead of using a double and an int, I'm going to define some types, price and quantity, and then I'm going to write my API in terms of those. And now at least when I write my expensive mistake, I'll name the two things, and then surely the compiler will catch something for me. But no, unfortunately, not in this case. Using and typedef are extremely valuable and powerful tools, but they aren't introducing new types. They're just purely aliases. They have their very important usages inside templates, inside other parts of your code where you want to shortcut names of things, but they aren't a new type. So this compiles just as well as the previous piece of code. Much better is to actually define real classes for both of those things. So if I define a class price and a quantity price, now I can rephrase my send order in terms of those concrete types. And for those that are used to passing classes as either const refs or pointers or whatever, you'll know that I'm passing these by value. The intention here is that a price and a quantity look and feel as much like an integer or a floating point number as possible, even to the compiler, even to the code generator, that we would pass them around by value. And passing value types around allows us to reason a lot easier about what things are or are not possible. There's no sort of spooky action at a distance from those, but that's for another talk. So now, if we compiled our expensive mistake, the compiler gives us this, which is a lot better. It says, hey, you can't turn a price into a quantity, and you can't turn a quantity into a price. That's a much better situation than trying to explain to your boss why you've just lost a load of money. So that's the kind of thing we're going to be talking about today. What does a quantity class look like? This is a really simple implementation of that quantity class. We're literally wrapping an integer. The only thing we hold in our class is that integer. We have a constructor that lets us create a quantity from an integer. And super key here is the fact that this constructor is explicit. You may have learned by rote that any single argument constructor should be explicit. This is why. If we didn't put explicit on the constructor, then the previous examples that we were giving, where we were just passing raw numbers, would still compile. The compiler would look at it and go, oh, I've got an integer when I needed a quantity, or I've got a float even when I needed a quantity. I can make a quantity out of that for you. And we definitely don't want its help in this instance. We absolutely want programmers to spell out when they wanted a quantity, when they wanted a price. And then we need some way for the ultimate user of our quantity to pull the actual number out again. And what I found with these types is that often you use these expressively through your entire system. And so you only need to get the value out right at the edge. And in my case, this would be only when we're binary formatting the message that we're going to be sending to the connection to the exchange do we actually need the numeric value. For the rest of the time, I can leave it as a quantity. If I need to add quantities and multiply quantities, I can write operators that do that for me. And I get a much more powerful sort of design element in my code as well. It's much less likely to make mistakes throughout my code base. So I might want to construct 100 units. So a quantity here is obviously a unit. I should explain a number of shares. It's a fairly common way of explaining in finance to say a quantity. I realize it's a very generic term, but in my world, a quantity is a number of shares. So 100 might look like this. And I can apparently also construct a -100 quantity, which doesn't make sense. I realize there are schools of thought in which negative quantity could be construed as selling and positive quantity could be buying. And there are finance, I know, does some funny things with bookkeeping, like negative prices and all that. But to me, this doesn't make sense. When I'm buying or selling something, when I'm sending an order, I'm not trying to buy or sell a negative amount of something. So might reasonably want to prevent this from being able to happen. So you might naively think, that you could just replace int with unsigned int. All I've done here is I'm now storing an unsigned int instead of an int, and I'm storing, I'm taking it in my constructor, I'm passing it in, and then I've got my value here, which returns an unsigned int. Everything is the same as it was before. Sadly, our quantity does not still compiles just fine. We're passing -100 in as an unsigned int, and the compiler is like, yep, sure, works for me. We actually have to enable this WSIGN conversion in order to get the compiler to complain about it. Again, this is mostly from GCC. I think Clang is pretty similar to this. I don't have enough experience on the Windows compilers to have a good instinct about what things are or are not. So this is mainly for the Linux compilers. So sign conversion is what you need to turn on, because this is a well-defined part of C++. It's completely reasonable, according to the standard, to initialize an unsigned type with a negative value. Things like npos in std string are, I believe, like size t of -1, which is to say the highest number you can get, things like that. So this is a well-established part of the language, unfortunately. So if you turn on WSIGN conversion in your code base, which I would encourage you to do, you might find a bunch of false positives that you'll need to put extra casting in to say, no, this is fine. That said, while I was preparing this talk, the code that I was working on at work, I turned on WSIGN conversion and found 2 actual genuine bugs. So it is worth the effort going through it. If you can't turn on WSIGN conversion, you just want to make your API itself much more explicit about what you can and can't pass in and construct a quantity from, then you can use tricks like this. Here I'm saying that the quantity constructor will take any type T, anything at all, and then inside the body, I'm asserting some parameters, some aspects, some traits, I suppose, of that T class to say that whatever the T is, it must be unsigned. Now I'll get an error message from the compiler at compile time if I try and construct it with anything that could represent a negative number. Great, right? If you are fancy pants, then you can have C++20's concepts, and frankly, anything greater than about GCC 7 will support F concepts at some level, and you can write code that looks like this, which is arguably better. Here I'm telling it that the T must be unsigned, but just in a different way. And now our code will error out in the compiler, telling us that, and maybe not the most elegant error messages, but it's C++, we're kind of used to that type of thing. It's telling me that, hey, this is not satisfied. The unsigned, is unsigned V is not satisfied when T is an int. And hopefully you'd intuit that, oh, it's an integer, I need it to be an unsigned integer. Which kind of leads us to the next point here. Rather unfortunately, now we can't construct it with 100, but the literal 100, because that 100, although it's a positive number, it is a signed type. We actually have to use 100U here. And I'll leave this sort of to your own discretion as to whether or not you feel that that's a more appropriate way. It's more honest, I think, to say, no, I mean this to be the unsigned 100, not the signed 100. But even if you are uncertain about which of those two makes the most sense, you still need to deal with the edges where maybe an integer, a signed integer, is coming into your system. And so that there, like maybe this 123 that I have in quotes here is something that someone's typed in the trading UI to say how many things they want to buy or sell. And we have to hope to heck that they haven't typed -100 in there, because we're going to have all sorts of problems here, because we're just blindly casting it to an unsigned integer, and with all the attendant problems that that's going to come up with. So although this is correct by construction, we're going to talk a little bit about runtime things that we need to check. So what we could do, what I like to do, is have the constructor be as I've shown, where it's pretty strict, but is compile time okay. And then I usually have like a runtime from static method where I can construct a quantity or whatever little value type it is from any T with a runtime check. So in this instance, we're taking a T and we're making sure that it's not less than 0. And we're also checking that it's not above the max value of whatever quantity representation, in this case, an int, because quite reasonably I could pass in an unsigned long into this quantity, and it could be outside of the range on the positive end too. And then once it passes the check, we delegate back to the constructor, making sure that we've done the cast to the unsigned version of our quantity, knowing that it's safe to do so. Oh, and I have slides for that. If you're using the GSL, and you should be, and if you don't know what the GSL is, it's the guideline support library that comes alongside the C++ guidelines, also worth Googling, looking up. If you don't know what those are, they are an invaluable resource. But the GSL provides a narrow sort of cast-looking operator, which does those checks for you. So it will check to make sure that the value that you're narrowing fits into the type that you're putting in, and it will throw an exception if it doesn't fit. So this is a more succinct way of achieving exactly what I had before, and frankly, less error-prone too. One thing you might want to do, I suppose it's worth actually mentioning before I go too far, in general, one doesn't tend to put lots of manifest constants of quantities and values and prices and things in one's code, especially in the finance world. You derive them, they're read from configuration, but this is more representative than it is. It's more illustrative, I should say. But one place I've found where one does need to construct these objects a lot are in unit tests, which you should write. And frankly, I'm scared by the JetBrains survey that came out that said many people aren't using unit tests. So write tests. And when you do write tests, you can make life easier on yourself. You can use user-defined literals to make it a snap to create the right type like this. So here I've made an underscore QTY user-defined literal, which just does quantity from. It has to be const expr, or rather, it should be const expr. And then the price, we're assuming that there's some price class as well. And I'm going to construct it from the dollar amount in this instance. So you could imagine having a cents class as well, which makes a price that's in cents. And something that I wasn't going to mention, but it hurts me so much. Never represent price with double. I know I did at the beginning. That was just to show up how bad this is. My price class that I'm using to sort of test out these theories here stores everything as integer number of pennies. So just words that are wise there. Excuse me. So anyway, going back to our original example, now my Google shares looks like this. Goog false 100 underscore QTY 1000 underscore dollars. And it's pretty succinct. It's definitely right. And if we got it wrong, the compiler would tell us. One thing I noticed, though, while preparing these slides is that, rather sadly, what happens if you suffer from a sticky 9 key and somehow you type in this gigantic quantity here in your code, in your test, I'm hoping? Well, that's a number that's more than 4 billion. It doesn't fit into the int that or the unsigned int that I'm storing in my quantity. What would you expect might happen? Well, I thought naively when the const expr-ness of the quantity meant that it would definitely be executed at compile time, and therefore the fact that it's outside of range and it therefore throws an exception would cause a compilation failure. But it doesn't, because the const expr doesn't require the compiler to run the code at compile time. The neat trick that, I say trick, this is kind of the design of it, I'm sure, but a revelation that I had was that if I make this in C++20, and if my clicker works, const eval, this says this function must be evaluated at compile time. So now, if I tried to compile that example before, the compiler tells me that that value is not representable as a quantity. And that's a really cool thing to be able to do. So const eval is a useful trick up our sleeves for user-defined literals in particular, where we know the compiler has to run it at compile time, or can, in principle, run it at compile time. So, we've solved the world's problems here. Having sold our Google shares, 100 for 1,000, we've got a lot of money in the bank, hooray. Now we want to reinvest. And so I'm going to buy some more using this function here. And, we're going to set past Goog, false, to say that we're not selling. Oh, except that's not what it was it? It's so easy to make a mistake here. Don't pass bools around unless it's absolutely unequivocal what that bool really means from just looking at the bool. Instead, do yourself a favor and make yourself an enum class. It's a strong type, so we will get a decent error message. We're just saying that it has two values, buy and sell. And now your code, it's just right by inspection now. It's correct by construction. So in summary for this section, use strong types wherever you can, strong value types. If you don't want to write your own, and maybe you shouldn't, but if you want to add your own sort of flair to it, then maybe it's a useful thing to do. If you don't want to use your own, then Jonathan Bacara has an open source project called NameType, which lets you make them pretty easily. Constrain your types however you can. Again, constrain them at compile time. User-defined literals I find very useful for tests. Don't use naked balls. And turn warnings on and make warnings as errors. And I'm going to pause here, and somebody has asked in the chat, does wpedantic catch it? I'm afraid I don't know. I haven't tried that one. I can try afterwards. I'm frightened to try switching out to a popular website that would otherwise allow me to test this. I did have them embedded in this at one stage, and for time reasons, I've had to take them out. So unless there are any other questions, I'm going to take a quick sip of something, and then I'll move on to the next section. Okay, thank you. The next part of my talk, I've called it enumerations. I couldn't come up with a better name. It's not a good name. We're going to talk a little bit about enumerations, but mainly through the lens of a so I'm getting distracted by the questions, which I'll attend to in a minute. So anyway, this is this part of the talk is sort of the other side of the finance coin. So you saw me sending orders to the exchange, which would my intention to either buy or sell. Now I want to look at the other side. How do I know what's going on the exchange? If I'm writing trading software, I need to know what the market looks like. And this is a picture from a really old trading system I used to work on, which sort of shows a representation of the interest in the market for a particular share on a particular exchange. So I think if I remember rightly, this is Twitter in about 2013. And what you're seeing here is from the bottom to the top is the price of the shares. And then at each level is the intention of someone to either buy or sell at that price. So you'll see that the blue means buy. So someone here is prepared to buy for 27.74, and there is somebody who's prepared to sell at 27.76. And then you can see all the other prices. So it's a little bit like an auction house in a way. And so a trading system will be observing this and making its own decisions about whether it would send an order at whatever price it sees is appropriate. Now, this is a static image. If you could actually see this, it would be flickering far faster than you could see, because these updates are coming in thousands of times a second for 8,000 symbols across 13 exchanges in mainland US and several across Europe. It's a lot of data. So how on earth does one keep up to date with this flow of information and sort of keep up and track? Well, the exchanges themselves send out to people who are plugged into them messages saying what has changed since the last moment from the last event. And those changes are orders coming in, an ad, orders changing in some way, being modified or by the person who placed them, M, or deleted, completely being removed from the book. And so it's a binary messaging protocol, and you get like a PDF from the exchange saying, well, this is how we're going to send data to you. Good luck with that. So, for example, it would probably have a header on the front of each message saying what sequence number it is, so you can tell if you've missed anything, how big the rest of the message is, and then a type indicator that's, in the case of one of the exchanges I worked on, was an ASCII digit, an ASCII, I guess a digit, ASCII character, either A, M, or D, to say what the rest of the message was. So the following bytes were either an add message, a delete message, or a modify message, depending on that. So let's take a look at it. First of all, I want to draw your attention to the first line here. It's actually a comment, and as I'm sure everyone here is aware, comments are uninterpreted by the compiler. They are unceremoniously turned into just white space before the compiler even sees it in most cases. And if you take nothing away from my talks other than this, look at comments and say, is there a way that I can turn this comment into an actionable thing that the compiler can help check? So here I've said must be 13 bytes long. Presumably the PDF I had said, oh, this is what the header is. It's a 13-byte structure that looks like this. Well, why don't I assert it then? Why don't I say, hey, the size of this should be 13. Now the compiler will check for me, and I can use static assert at the top level of the file. It doesn't have to be in a function. And I can say, if it's not 13, it's an error. And indeed, in this case, in my slide implementation of the market data handler, this was not, in fact, the case. This is not a 13-byte header because the structure is not packed. So it'll be aligned to the 8-byte boundary of the biggest type here, the UN64T. This is unimportant. This is not part of the talk, really, but I find it's kind of cute to use the attributes now that we have in C++ 14, I think. One of the newer C++ has brought in these attributes, and you can use the GNU extension here to say, hey, this is a packed type, but don't worry about that if it doesn't mean anything to you. How might we write a handling system that takes a stream of these packets coming in? I'm going to assume that there are 3 functions that are overloaded on the type of add, or a modify, or a delete. I've got this horrific shim template function template even, sorry, that says, given some arbitrary payload, let's interpret it as the right type of data and dispatch to the appropriate function. And I'll leave it as an exercise to the reader as to whether or not this is valid without the upcoming standard interpretations of data as objects and all that kind of stuff. So I'm not going into that right here because that would be a whole other talk. And then we're going to write this onMessage function. And the onMessage function is going to be given the header and some payload that came alongside the header. A reasonable way to write it, certainly the shortest way to write it, is to use a sequence of if statements. And so we just check the type. Oh, hang on. I forget which things are lighting up or not. We check the type. If it's an A, it's an add. If it's an M, it's a modify. It's a D, it's a D. And we're done here. That's pretty straightforward and pretty easy. It's more code, but I would argue probably more idiomatic to write a switch statement here. It's a little clearer, I think. There's the extra break that you have to write in there, but we still are switching on an ASCII character where that seems sort of less intuitive at the point of me writing this piece of functionality, what's going on. Far better for me to go back to my original definition and change it. So instead of being just a char in that structure, I'm going to use an enum class, just like we did before with the by or cell. It's going to give me a strong type. And I'm going to say, no, this is a colon char. This means that it is a char-sized strong type called message type. And I can say, I want an add, a modify, and a delete. And then here and only here, I'm going to encode the magic that the A is the add, the M is the modify, and the D is the delete. Nowhere else needs to know this. That's a great change of itself, because then it goes into the one header file that has all the horrible binary nonsense, and then everywhere else just uses nice C++ constructs. So then we go back to our header and we modify it to say message type instead of char type. And our static assert protects us to make sure that we have not accidentally made it a bigger structure. So that's a great improvement. And now our handle class looks, I guess it's very dense on this slide, but our handle class now does a switch on the type, and then the case statements are phrased in terms of the symbol add, modify, and delete, not the characters that we had before. And so that's an improvement, I think, in readability. In this particular case as well, I'm actually returning on each of that line 5, line 7, and line 9, which is a cute trick to make it fit on the slide. If you're in a void function, you can actually return calling another void function. I don't recommend it, but what this means is that at line 11, I know that it must have fallen through. It was neither add, nor modify, nor delete, so it must be something we didn't know about. Now, you could use a default here, which would be a catch-all for all the other things that would potentially come through in that header.type, but I'm going to recommend against it. Why? Well, what happens if we forgot a case? What happens if we forgot a message type? And in fact, we did. We forgot that it's not just adds, modifies, and deletes. There are perhaps trades as well, and maybe other things. So we're going to add a trade message in. I was reading my PDF. I went, whoops, I forgot about page 2. Turn over the page, and there it is. So a trade message can come in and tell us all the things that happened and traded on the market. And that will be, I just put it in the message type here as a T. Like that. And now the compiler leaps to our leaps to our aid here. Because we didn't put a default case in, and we covered all of the cases before, the compiler will tell us, at least with the relevant warning levels on, which I recommend, that we haven't handled all the cases that can happen. And that's actually a useful side effect. So we're immediately going to get an error anywhere in our code where we were switching on what that type could have been. And this is a great way of finding all the places in your code where you perhaps do need to think about, well, what if a trade gets to this bit? What happens if my system is in this state in this part of the code? It's less useful in this particular example because from the code that I showed you, that would probably be the last time that we'd ever use those literals. But in the case where you have a state machine where you've got like a half dozen states, adding another one means that anywhere that you're switching on your state machine, you're going to get an error saying, hey, you ought to think about the new state you introduced here. Now, obviously, you have given up the default, but I'd say that sometimes that's the right trade-off to make. So in summary here, static assert is your friend, and it can be used outside of the body of functions. I would recommend using enum classes for any of the choices, state machine, or even for size ones, like if you have a binary protocol you're adhering to. I'd say avoid using cascaded if and else if to check on these things, which you probably would do anyway. It's a fairly standard thing to do. But the sort of more contentious thing is that for these types of things, a no default switch is a good thing to do, because then you get the compiler's help when you add something new to the switch, to the enumeration. Turn warnings on, make sure warnings are errors. So I'm going to pause there, and there's a question that says, is it better if we use GSL not null as the parameter symbols type? That probably is a better thing. Probably a const standard string or a string value might be better, because the GSL not null, I don't know if, would it, I'm not certain that a quoted string literal would be turned automatically into a GSL not null. It might be, in which case, yes, absolutely. Specifying the non-nullity of something is a better example here. I didn't actually think to try changing the symbol. In reality, in any trading system I've ever used, we actually have like a long-lived symbol object rather than the string. So that tends to be the thing that gets passed around, a const ref to the symbol. All right, we're going to leave finance now. And I'm going to click the button. Talk about a sort of broader comment of, broader topic of comment smells, which I don't know if it's the right term for this, but you can be the judge of this. What I mean is this kind of code. So we're, as I say, we're no longer in the world of finance. We're now in some kind of GUI library where you have a widget, and that widget is accessed potentially from multiple threads. So it has a mutex, and it's got some internal state. And from time to time, we want to go in and tinker with the internal state of the widget. And for whatever reason, the tinker with doesn't have locking built into it. Perhaps there's some atomicity guarantees that we need to do if we do multiple tinkers. Whatever, just go with it. So let's have a look at the kind of things I'm talking about when I mean comment smells. Well, the first thing is tinker with. The comment above it says must hold lock. And then we say, okay, let's look at lock. And it says, don't forget to unlock. And likewise on the unlock, it says you can't call this unless you actually did the lock here. So that's three relatively complicated interdependencies in your API, which is pushes the onus of responsibility onto the poor caller, the poor user of your API. Can we fix this? Can we make it better? First of all, let's just take a quick look at the kind of problems that we're going to see if we were to use the API as designed. We have to remember to lock it. We can now tinker with it a bunch of times. And we have to hope that none of these things throw exceptions, otherwise the thing's going to be locked forever. And we have to remember to unlock it. Otherwise, the thing's going to be locked forever, and presumably your poor program's going to grind to a halt and not even really crash in a meaningful way, just stop. But the obvious first thing that we can do is hand back a magic token that says, while you're holding on to this token, the widget is locked. And then we know that when the token goes away, the widget will be unlocked. And the way that we can do that is to use a scoped lock. So here, the lock method, we've removed the unlock method, and the lock method returns back this scoped lock that says, while this object is alive, I'm guaranteeing that the lock on the widget is held. And then as soon as I fall out of scope and my destructor runs, then I'll do the unlocking for you. And that's great. That's a huge improvement now, because now we don't have to remember to unlock the widget once we've locked it. Unfortunately, if you've got a big code base, you'd be forgiven for making this kind of mistake. You saw that I deleted the unlock. And so maybe I get a bunch of compiler errors telling me that, hey, look, you're calling unlock here and there's no such function unlock, and you just delete those lines. So the code that we had before now would look like this. And if anyone could spot the mistake, so this is where if we were really in front of me, I would pick on someone. But the problem here is on line 2, we're ignoring the return value of that lock. The token that it gave us, the scoped lock that it gave us, is being discarded. So in widget.lock, we are locking, returning a scope lock. The scope lock is thrown away at the semicolon here. There's nothing holding on to it, which means that we immediately unlock it. And now we're tinkering with an object that is not locked. So this is actually worse than it was before. We had working code and we broke it. We can fix this by using the no discard attribute on the scope lock. We're saying if the caller doesn't do something, where do something is a bit looser defined, but at least hang on to or put into a variable the return value of this function, then it's an error. So just by adding this no discard, we would get this error now saying that we're ignoring the return value of lock, which was declared with attribute no discard. And that's a huge boon for us as API designers, because we can tag things and say, look, hey, don't make this kind of mistake. You meant to do something else now. And of course, that something else is to do just something like this here, where we're just assigning the lock into a variable, and the lifetime of that variable will mean that the lock is held until the variable goes out of scope on line 5 here. So that's a bit of an improvement. So there's another thing that was there, though. So we've got rid of the unlock apology, but we've still got the must hold lock part of the of the widget interface. So it's still possible for us to make the mistake where we can tinker with the object having not locked it. Can we fix this? Well, yes, I guess is the simple answer to that. There are many ways to do this, and I'll show you a couple of the potential solutions. The first is to hide away the tinker with function. So in this implementation, I've now made the tinker with a private member of the my widget. So nobody can call tinker with anymore, except that I am defining an inner class, tinkerable, which will implicitly be a friend of my widget. And then the only way that a user can interact with the widget is to get an instance of that tinkerable sort of wrapper, I suppose, is what it is. I keep saying interface, but it's not really an interface. It's a wrapper. So what does that tinkerable look like? It's a bit of a block of code again, but effectively, the tinkerable holds a reference back to the widget, and critically, it holds the lock on that widget too. So it's bound together the widget with the lock. Excuse me. In its constructor, it just initializes the widget reference and then locks the mutex. And of course, it's a scoped lock. So as long as the tinkerable is alive, the lock on the widget is alive. And then instead of the caller calling tinker with on the widget, they call tinker with on the tinkerable wrapper. And that just simply delegates straight onto the widget. So this is visible to the compiler. It's almost no performance, should be no performance impact, which I haven't really talked about, but none of the things so far I've talked about have any reasonable performance impact in my experience. So we're essentially using the tinkerable as a way to subvert the private nature of that tinker with by wrapping it, with the guarantee that the only way I can get hold of a tinkerable is to have a lock on the widget. So now this is what my code looks like. I get a tinkerable, and then I can fiddle with the tinkerable to my heart's content. And I know that I couldn't have called widget.tinkerwith because it's not accessible to me. Instead, I have to get a tinkerable, and now it's a locked widget. I guess I could have called it locked widget, really. That would have made more sense, wouldn't it? Now I think about it. Oh, well. Doing it live. So that's one approach. Another approach is to hide away, again, the internal state of your widget. In this instance, I've wrapped it into a widget state class, which has the tinker with. And then instead of allowing the caller to reach in and poke into the innards of my objects through like a tinker with method, the caller says, I'd like to make a change, please. And here is something that explains what kind of change I'd like to make. And I'm using a function as the explanation, the way of wrapping up all of the changes that one might want to make to the object. So the tinker function inside the widget looks like this. It just takes out the lock and then calls your function with the internal state, which you'll notice was hidden before. And in fact, if I go back a slide, because I forgot to mention something, this widget state class is a private class within my widget. You can't even declare it outside of my widget. What that means here is that when I'm implementing my tinker function, sorry, when I, the API user, want to tinker with the widget, I call widget.tinker, and then I have to get a reference to the tinkerable interface that it's going to pass. This is like not the tinkerable interface, I apologize, the internal state, that widget state that I can now change. And I have to use auto to grab it because I can't name the type. This stops someone from like writing this and taking a reference to and storing it in a variable that lives outside of the tinker function. That's a bit of an advanced topic. You don't need to think about that kind of stuff because most people aren't going to try and leak out of a Lambda the pointer to something they were given inside the Lambda, but it's possible. Anyway, this is what you'd end up doing is you say, I'd like to tinker, and then you call me back with the thing that I can now mutate, and I know that the lock is held for the duration. Moving on to other comment smells, and now we're going to move from the land of UI widgets into a bit of sort of graphics-y type stuff. Again, completely made up interfaces just to illustrate points here. One might be writing a graphics program, and there are many shaders that you want to bunch up together and run some compile and link step between those shaders. So shaders are usually little bits of text that explain how graphics should be rendered on the screen. I apologize for butchering that description, excuse me, but it doesn't really matter for this. So you could reasonably have some kind of shader registry where during startup you add in all the shaders, and then you call compile, and it does some compilation, does some kind of cross-analysis of the shaders, works out duplicates, does whatever magical things it does behind the scenes and prepares a graphics card or whatever. And then you want to get the result of a compiled shader out, and then you can presumably use it to plot sprites, whatever people do in games these days. Now, you'll notice this also has the apology comment smell of must be compiled and linked. So already there's something we can change here. And hopefully it's a pretty straightforward and obvious thing to change. But the first thing we could do here is separate the two hats that our registry was wearing before. Previously, it was both the compiler and it was also like the repository of the results of compilation. So if we split that in two, then our shader compiler we can add things into, and then we call compile, and we get a block of compiled shaders, which of course is no discard, but this is obviously potentially a very expensive operation. We don't want someone to accidentally call it using like the old style API. We're going to say, no, you have to hold on to this into a variable. And then that variable will be of type compiled shaders, and then this will have the get compiled. So I can no longer even get access to get compiled until I've already compiled my shaders. And this is about the second time I've talked these slides, and I'm realizing that we've got so many compilers and compile things going on here, it's a bit confusing. So hopefully you're following along. So we've separated the concerns here between the compiler and the results of compilation, which is a sensible design decision to do anyway. And this is what our code would look like. We add our two shaders, we call compiler.compile, we get Bob back out again, and we call render on him or something like that. Now, what I've discovered is that oftentimes with these kinds of expensive operations where reasonably you might not want to repeat them, is that it makes sense often to take some aspect of the compilation process and move it into the results of the compilation process, or whatever, some kind of aggregation that you might be doing. So here we're saying that, well, if you call compile, whatever resources that you had added previously have been kind of moved into the compiled shaders. So the shader compiler is like a thin, empty husk of a class once you've called compile on it. And so don't go expecting that you can add more shaders and compile again. That's not going to happen. You have to throw this away. It's done. And so obviously here's a comment explaining that. And can we get rid of the comment? Can we somehow explain a way to the compilers to give us some help? Well, I wouldn't be saying it if there wasn't at least something. This is the weaker of the correct by construction thoughts so far. I'm calling this destructive separation. It's not really a good name. Doesn't make as much sense. But this is something that, unless you are knee deep in the innards of the C++ standard, you probably have never seen before. I certainly hadn't seen it before, and I definitely have hardly ever used it. But by putting a double ampersand, that is the R-value reference qualifier, where you would kind of normally put const, you are changing this pointer's R-value-ness. Now, that doesn't make any sense to anybody, I realize, but what this is saying is that compile method is only valid if the shader compiler that it's being called on is a temporary, or is about to die, about to fall out of scope, or has been moved from. And that's a powerful way of us trying to express to the compiler that this shader compiler, is no good anymore after this. It's gone. If we were now trying to call compiler.compile, we'd get this somewhat perplexing error message, but at least it would prevent you. So if we were to run the code as it was on a hypothetical line 2 of this example, there would still be a compiler object around, which we could potentially call compile on. And the compiler and the C++ compiler is telling us, no, you can't allow that. That's not allowed to happen anymore. So here it's saying that the this pointer is not the right type. It's not an R-value reference. How do we fix that? One way is to call std move on compiler, and now we get an R-value reference to a compiler, and we can call compile on that. That at least gives a hint to the to the reader of the code that something is going on with that compiler. We are moving from it, and hopefully your spider sense would start tingling at this point to say, well, I probably can't do anything with that compiler anymore. Sort of more natural way of phrasing it is to separate the use case as well. So here I've separated my example into a stage that does all the compilation and then a stage that does all the using. And the stage that does the compilation doesn't have any funny moves in it, because on line 5, where I'm doing return compiler.compile, that compiler object is going away, and the C++ compiler knows that it can use an R value reference to it there. So there's no unnatural looking code there, but no surprising code there. And in our use part, we just call compile and get a shaders object back, and we're good. We know the compiler knows that variable called compiler is never going to be used again after line 5. But what if we were to accidentally, ignore the stood move case and call compiler.add on some other new shader after we'd used it? Really sadly, right now, the compilers don't give you any kind of warnings on this, because their moving from is not as well defined as some of us would like. So unfortunately, this is not really correct by construction in this, but hopefully the API hint of it being stood move from is enough. That said, if you use Clang Tidy or another static code analyzer, and you should be if you can afford to, Clang Tidy being free is relatively low impact to get into your code base, then it will tell you about these kinds of things. It does a much deeper analysis. It takes a while, but it's worthwhile. Here it's telling me that, like, hey, you can't call compiler.add because you moved away from the object. So that's a worthwhile thing thinking about, is static tools. The summary for this section is, you protect your invariants with code. So there the initial widget example was all about protecting the invariants of must be locked when you call this function, or must unlock when you've locked, those kinds of things. The clue for this is those apologetic comments, the must be or should be or how do we. Separation of concerns is always a good thing to do. Just from a design point of view, as well as a way of ensuring the lifetimes match up with decent expectations. And Clang Tidy wants to be your friend, and you should be its friend. I'm seeing a question coming in here. If in your shader compilers example, we know all the shaders at compile time, is there an opportunity to enforce compilation is only performed once using constexpr, maybe in a constructor? I'm not aware of that. I imagine there could be. I'm not very creative when it comes to constexpr. So I'm certain that if we chatted afterwards, there are ways to make it happen. But yeah, constexpr, given the compiler's sort of myopic view of one translation unit at a time, I don't know if that would be in general possible. But maybe, perhaps in the general chat, people can talk a little about that. Thank you, Joshua, for your question. Sorry, it wasn't a very rewarding answer. All right, in the final sort of 10 odd minutes, I'd like to talk about RAII, which is that dreadfully named thing that we all know and love. And for a long time, I used to describe RAII as the sort of killer feature for C++, like the one must-have feature that it had over most other languages. Nowadays, I think that the strong value types thing beats it. I've found more uses that are surprising to other language users about using strong types that are really cheap to throw around than I have for RAII, but it's still a very powerful construct. Of course, RAII stands for Resource Acquisition is Initialization, which is probably the worst acronym in C++. It is not just for resources. I don't know about you, but when I think of a resource, I think about memory. Maybe at a push, I think a file handle. Not anything else, really. It's like very much a physical thing that lives kind of outside of my process, even. A better name for RAII is perhaps CADR or cadre or cadre or however people want to pronounce that. But constructor acquires, destructor releases. That sounds a little bit more general purpose than resource, at least to my ears. Let me give you some examples of other times that you can use RAII. So I guess actually it's worth mentioning that we've already used RAII in some of the examples before. The scoped lock that we were using earlier was an example of an RAII object. And in this instance, the resource was the mutex that it was acquiring and releasing. But we were relying on the fact that the constructor did something important, and then the destructor did the opposite of that and kept everything nicely in balance, and we didn't have to think about it. So returning to the sort of UI mental model here, although many things can be modeled this way, who hasn't written or seen code that uses like a listener style idea? Certainly if you're into OO design, this is the sort of meat and drink, where one is going to define, if my clicker works, a listener interface that a caller of your API would implement. And whenever something interesting happens for the type of object that you're registering with, it will call you back with on event saying, hey, the interesting thing happened. The mouse was moved. Somebody clicked on your button. However your application works. And then you subscribe yourself to a particular event source and say, hey, when something interesting happens on you, let me know, please. And obviously, there is an equivalent unsubscribe. I'm no longer interested in what you're doing here. And this has long been the kind of an important part of any kind of UI-based thing. And the trick really here is that one has to remember to unsubscribe, not just when one is uninterested in the event anymore, but as your object is going away, you better make sure that you unsubscribe. Otherwise, the poor event source is going to be calling onto some long deleted object. So again, looking at line 8, you can see that this is the don't forget to or must style comment that we can replace with, of course, RAII. In this instance, the name of the token, which was a scope lock in the last thing, the name of this sort of object, this RAII object that I'm going to return, has a natural name. It's a subscription. If you subscribe to something, you get a subscription. You can cancel your subscription. You can get rid of your subscription. It's kind of useful that we have a name for that. Sometimes there aren't as obvious a name, but maybe in other systems you might have reservations, or you might have, that's the only one that comes to mind off the top of my head. Stay on script. So here our subscription is very much like the scoped object that we had before. It binds together an event source with a listener, and it keeps the invariance. That is, I add myself to the listener when I'm constructed, and when the subscription goes away through whatever means, I remove myself from the listener. And so the expectation is that most listeners will probably embed a subscription in their own object. That way, when that object goes away, it will automatically unsubscribe from the event source that it was attached to. If you need to unsubscribe earlier, you can either make it so that the subscription itself has an unsubscribe method, in which case you need a bit more tracking to remember if you're still subscribed or not. Or you can use a stood optional subscription in the thing that you are storing it into. One thing that's really worth pointing out here is that you have to remember to implement the special member functions. So what do I mean by that? I mean, we must make sure that you can't copy the subscription, but we probably do want to allow moving so that we can return them from functions like the next page, which is we're going to replace subscribe and unsubscribe with add and remove and make them private functions now. And then the subscribe public method is a no discard. Remember, we need to make sure that nobody is accidentally calling the old API with the old expectations. A no discard subscribe, and it just returns a subscription that binds the two things together. So this is a very short thing. I don't think I need to labor too much the differences between RAII and or the new things that I've covered. But it is worth saying that there are other ways that you can use RAII in your code or Cadre. Only recently I started using it to track indentation depth within a pretty printer. So, whenever you indent more because you're doing some other new printing or whatever, one could construct a little object that says, no, indent a bit more, knowing that when it falls out of scope, we can undent by the same amount. You can use it to track things like recursion depth. Reentrancy is another one. So if you have like a Boolean that says, am I already processing an event, which is very typical, like in your UI library, the thing that's dispatching to all of the listeners is essentially iterating over the list of listeners, right? It's got a vector or a list of actual listeners to call back, and it's saying on event to you, on event, on event, on event. The problem that you typically have when you're writing that kind of code is that what if one of those listeners decides to unsubscribe while you're iterating? You've got the classic problem of a list or a vector changing while you're iterating over it. So normally what you either do is disallow it, or you have a much more complicated system for doing it. But the simple way of disallowing it is to have a Boolean that says, am I in the middle of iterating in your event class? And then any of the subscribe and unsubscribe methods maybe throw an exception if that Boolean is true. That means that Boolean has to be true while you're iterating and definitely has to be false at all other times, however you come out. It's a perfect example of using a little RAII object who will set the I'm iterating to true when it's constructed and then set it back to false again when it's destructed. And there are things like, I can't remember what it's called now. There's a boost and I think even a stood thing that allows you to just do this, make a little RAII object on the fly. And if someone can put it in the chat, I've just completely dropped the ball here. So I've forgotten. Another thing that I've used RAII style objects for are little timers. So little things where I construct them at the top of a function and then they take the time, and then in their destructor, they take the time again and they either log or warn saying, hey, this took a lot longer than I thought. It's a great way of measuring how long a routine took. So that's kind of all I have for you today. The main conclusion really is there are tools and there are ways of letting the compiler help you if you know how to use them. And there are many other techniques, I'm sure. But just to quickly go over these, look for those comment smells. Try and find a way to phrase what would be a message to a human into a message to the compiler. Sometimes you can get rid of the human message because the compiler message is good enough for both of you. Other times you still need to have an explanation of why. Turn on warnings. Put them up to as the highest setting you can possibly suffer with, and that should be pretty high. You should have a high tolerance for warnings. Make them errors and fix them. You'll be surprised at what you'll find. Actually, only earlier today, I've just open sourced some code from 1995 that I wrote with some friends of mine. And in bringing it from the C world into a modern environment, I turned on all the warnings. And it took a whole weekend to fix all the warnings. But I found so many issues and so many how did this ever works, which is worthwhile. Use strong value types. They are one of the jewels in the crown of C++. And of course, RAII or cadre. Someone tell me how I should say that. So that is my talk. Thank you very much. I've appreciated this. This has been an amazing experience of talking into thin air, but knowing that you're all there. So thank you very much. And I'll take any questions if there are any. I'll stand here and wait if there. I know we've got a little bit of a lag before anything turns up. So I get to talk to myself as people who know me well. Oh, there we are. Can I show? Yes. Can I show the amp thing? Yes. This will involve me getting my keyboard out. I should have pointed out that the slide numbers are at the bottom. You can't make it work. Okay. I'm going to click on that. Now, the way that my screen is currently set up is that you won't be able to see anything other than my slides tab. So although I can see the compiler explorer link, foo.done. Oh, golly, you're absolutely right. So what Max has done is he's shown, and I'm going to get the slide up again. Somewhere in here. Oh, no, it was in this section. I think he showed this equivalent here. And actually, I'm sure I checked this, but I agree with Max's assertion that that doesn't actually work. So I apologize. I thought I checked this. So scratch that one from the record. That's rather unfortunate, darn it. So that line 5 here that I'm highlighting will have to be the return stood move of compiler.compile, I think. Let me just check in Max's example to make sure that that actually does compile, and we've at least got some idea about. Yes, that seems to be. Oh no, it wants me to include utility. Again, you can't see what I'm typing here, but I'm frantically using this website. Yes. So we need to be moved. Okay, unfortunately, that's not the case. That was obviously wishful thinking on my part. Sorry, everyone. So I'm going to move on to the next question with my tail between my legs slightly. Is the compiler clever enough to throw away the copy of the event source reference that is needed for the destruction of the subscription wrapper? So I think what Mike is asking here is the copy of the event source reference. No, I don't think the compiler can throw that away because it's part of the object itself. And I think you're referring to the fact that my event source has both a reference to the source and a reference to the listener. So it's essentially on a 64-bit machine, it's essentially 16 bytes of object. event source reference, listener. Yeah, I don't know that it could throw it away necessarily, because under what circumstances could it be thrown away? I suppose if it was on the stack, if your subscription was on the stack, the compiler might be able to see through it. But the trick here is that it could be dynamically different as to when it goes away. Maybe you're storing it in your own object, so you could have a class that has a subscription in it, and that needs to track both of those, event source and listener. I suppose it is, if you know it's definitely going to be embedded inside of an object, then there's kind of there's an argument that says, well, can it be clever enough to know that it's an offset from its own position? And I know that in the C world of the Linux kernel, they do this all over the shop, and it involves all sorts of horrible pointer manipulation. So I think the short answer is no, and probably not. I've not ever known it be a big problem in these kinds of issues, but it's an interesting question. So thank you, Mike. And again, apologies for showing code that I thought worked, but actually doesn't. Okay, I think that's it. So thank you all, and I'll join you in the chat shortly.